All right. Good evening, everyone. Welcome to the April edition of the Astro Imaging Special Interest Group. And this evening, we're going to have kind of an open discussion format, but I'd like to start off, first of all, by asking any folks who this may be your first meeting to please take a moment and introduce yourself. Is there any new folks just joining us for the first time?
Not quite
Hi,
the time,
go ahead. Sorry.
but it's been about I'd say 2 years. I was at one meeting during COVID, and then problems with getting emails and notifications and things. So I just figured things out. So I'm back.
Well, welcome, Jim.
Thank you.
Anybody else?
Hey guys, it's Jim Long, and I've actually listened on a meeting or two, but tonight I have a question, so I figured I'd say hello and introduce myself.
Okay.
Doug Davis, and I have attended a couple of meetings, but I don't think I've actually participated. So, good evening.
Okay, welcome aboard. And usually at the beginning of the meeting, we spend a few minutes if there are any beginner type questions. Nobody likes to admit they're a beginner, but every once in a while they have questions. So are there any beginner? Jim Long, go ahead.
Hey guys, I just am putting everything together to start imaging with my C11, and I have a ZWO 533 MC and a ZWO 120 MM for guiding. And I've been trying to figure out where all the cables go and how things connect together, so Nina will be happy. And I noticed there's two paths that I could take with the guide scope. One is I plug directly into the mount with the cable that came with it, or the second is I plug into the back of the 533 MC. I don't know what the right answer is. It's certainly shorter to go from the guide camera down to the 533 MC, but is there a better way to do it? Directly from the camera to the mount. I have an EQ6R mount that has a guide port, and so that's my question.
Well, I'll tell you what, since we're going to be talking about guiding this evening, why don't you hold on to that question? And I think we'll get to the point where your question will be pertinent. And so just hold on to it, and I think we'll get to it. And if we don't, we're going to have plenty of time at the end to go back over it. So hang on to that question. That's a good question. I think you probably get a couple of different viewpoints on that. Any other introductory types of things? Okay. Well, what I'm going to do this evening is going to try to lead an open discussion. And by open discussion, I mean I'm going to put some bullet points up, and I'm going to ask for folks to comment or question as we go along based on what you see on the screen. So I'm going to roughly go from really basic introductory terminology kind of things to equipment, and finally then to software. So if you have a software question, try to hold that till we get to that part of the bullet points. But again, I encourage you to feel free to jump in at any time. You don't have to hold your questions to the very end, or particularly if you have comments. When I say something that sounds unusual or wrong, please feel free to jump right in. All right, can everybody see my screen? Hello?
Yes.
Yeah, okay.
Yes, we can.
All right. So again, as I said, we're going to start with some really basic stuff because I wanted to have something that was appropriate for someone who's just starting out, as well as for some of the more seasoned veterans. And I'm expecting that the seasoned veterans will be happy to jump in and share their thoughts and feelings. Again, as I go through some of these bullet points, I've highlighted some of the important terminology in blue, so just to kind of keep us on track as to where we're going. I guess the first question that most folks think about when they think about guiding is, does it apply to all different types of astrophotography? And I guess the answer to that would be not necessarily. So if you think about the types of things that we routinely do, you see them listed here: wide field, lunar and planetary, solar, and then deep space. For things like wide field, what we sometimes call nightscapes, there's usually minimal, if any, guiding required. Many times you can do it without even any sort of a tracking mount. It can be done just with a tripod. For lunar and planetary and solar imaging, because the targets tend to be very bright, it's generally the case that you don't have to worry about guiding. You may have to worry about tracking the sky, but you don't necessarily have to think about guiding the telescope in order to capture those targets. And for most of what we're going to be discussing this evening, I guess, applies to the last category, and that is deep space targets, where we're taking prolonged exposures, and those do generally require guiding. Any questions or comments on the first slide here? All right. So when we think about guiding, or when I think about guiding, I guess there's a couple things we want to make sure we're on the same page for. And first of all, there's a difference between tracking and guiding. And I see a lot of times people talk about getting their scope polar aligned, et cetera, in order to point the scope. And sometimes that applies and sometimes it doesn't. But again, tracking simply talks about or considers a amount that compensates for the rotation of the Earth. And we generally consider the equatorial mount as the type of mount that we're usually talking about when we talk about a tracking type of mount. Guiding, however, is a slightly different animal. And guiding requires a mechanism of some sort to adjust the tracking of the telescope so that it better follows the sky in order to make those longer deep space exposures that we've already kind of alluded to. And I've put at the bottom there unguided, because we hear a lot about doing imaging unguided, and typically that refers to a mount or imaging system which is accurate enough that guiding is unnecessary or minimized to a great extent. And typically that requires a very sophisticated or expensive mount, as well as an imaging system that may be set up to handle that unguided imaging as well. We'll talk a little bit more about that. So any questions about what we're going to be talking about in terms of guiding? All right, I'm doing good so far. No questions. Okay, well, I guess the second question is, do you really need to guide? And the answer to that is, well, maybe, but maybe not. And I think this, in terms of the actual taking of an image, the things that we think about are the focal length, the focal ratio, and how long the exposure is. And so it's kind of a rule of thumb that if the focal length of your imaging system is very short, that becomes a much easier system to manage when it comes to making sure that the stars turn out as pinpoints on the sensor. Conversely, if you're talking about a focal length that's very long, in this case, an example might be a 2000 millimeter focal length like you'd have in an F10 C8, then that requires a great deal more expertise and equipment in terms of making sure that you can guide properly. And you can think of Charter in a lot of different concoctions. As short as a simple camera lens might be 20 to 35 millimeters, where you can shoot off of a tripod and get decent star images with no guiding or no tracking whatsoever. The second aspect, I guess, that we think about is the focal ratio of the imaging system. And again, the rule of thumb here is faster is better, faster is easier. And those of you who shoot with a hyperstar operating around f2 or so realize that it's much easier to get the data on, you get the photons onto your sensor with that fast optical system than it is if you're shooting at something like f6, f7, or even f10. So again, the focal ratio makes a big difference as to whether you have to guide or not. And of course, using one of those very fast focal ratios like f2 many times will allow you to gather the appropriate data in a good fashion without guiding at all. Finally, the exposure length, and the rule of thumb there is that it's better to do a short exposure if you're worried about guiding than to do a long exposure. And that comes into play because of the characteristics or the mechanics of the mount that's tracking the sky. It's generally easier for a mount to track for a short period of time than it is for a long period of time, because the longer you go, the more likely you are to run into some issue like periodic error or some other defect in the, not necessarily defect, but mechanical limitation in the mount that only shows up when you do a prolonged exposure. So again, you may not need to guide if you're using a short focal ratio, a short focal length, a fast F ratio, and short exposures. And so we see a lot of images posted where those criteria are all met. On the other hand, what we're really kind of interested in is looking at what do you have to do when you don't meet those criteria, when your focal length is not necessarily short or your focal ratio is not the fastest that you can imagine. Any questions about those three concepts that are behind whether or not you need to guide? Comments or questions?
Doug, it's Jeff. I would just add another explanation on your third point, that even the best of mounts are not perfect, and with seeing conditions and atmospheric conditions, the sky is not perfect in the sense of being exactly where the mount's computer expects it to be. So the shorter exposure there may be an error there. It just doesn't show up in 60 seconds, but when you go for 5 minutes, the error will just keep adding to the image, and so that it will over time become apparent. I don't think it changes the analysis at all, that yeah, shorter is absolutely easier, but it's another reason why it's harder to go long.
And I think that makes sense. And that's why we see a lot of imaging systems being used nowadays that aren't a long focal length. I mean, how many of us bought an F10 Schmidt-Cassegrain telescope and said, "Oh, this is great, and I'm going to start taking pictures," and then very quickly learned that at 2,000 plus millimeters and F10, even a very short exposure became very difficult to do. So yeah, I think that all of this kind of combines to help us decide whether or not we actually need to do guiding at all. Other comments or questions? All right. So do you need to guide? Well, in addition to those three factors that we just talked about in terms of the image themselves, in terms of the equipment, the type of scope many times will dictate whether or not you need to guide. And we've already talked about the focal length and the focal ratio, but the type of scope itself sometimes comes into play. For example, Newtonian reflectors are used a lot because they're light, they're fairly cheap to implement. But again, the mirror and the focusing system in those types of telescopes can be problematic when it comes to trying to make sure that the star stays on the same point on our sensors. possibly the most villainous type of scope is the old classical Schmidt-Cassegrain, either with or without a hyperstar attachment, because of the fact that the unmodified scope has a mirror that can move around quite easily, particularly when you're trying to do things like focusing. And so there are a lot of hoops that you sometimes have to jump through in order to stabilize the mirror in the off-the-shelf Schmidt-Cassegrain type of telescope. And so it becomes one of the ones that many folks have difficulty with when they start trying to take long exposure images. Perhaps the two most easy to manage systems are refractors, and I guess a camera lens is the simplest example of a refractor type of imaging train. But again, because the optical elements in the refractor don't move around like a Schmidt-Cassegrain, makes it a little bit easier to guide that type of scope. The focuser comes into play on refractors just like it does on Newtonians or Schmidt-Cassegrains, that we don't have that problem generally on camera lenses because the focusing is kind of built into the lens itself. And then last but not least, and probably one of the more important aspects, is the type and quality of the mount. And I've just listed a couple types here. Hopefully you're familiar with the sky tracker type of device. That's what you might use with a DSLR to take wide field or nightscape type images. And typically those sky trackers are an offbeat equatorial mount in that they usually track in right ascension, but not necessarily in declination. And so that would be the simplest type of mount appropriate for short focal length systems like a camera with a short focal length lens, or maybe a small refractor. Probably the one that most of us are familiar with, and we're going to spend most of our time talking about this evening, is the equatorial or German equatorial type mount, which most of us use for deep space imaging. And I listed also the C-star, which is something that a lot of folks now have experience with. Originally, the C-star was an alt-az device that used alt-az manipulations to track the sky and then compensate for that by the software that was built into the device. But they've recently introduced into the software a way to use it with an equatorial mounting, so that if you have some sort of a wedge device or a tripod that you can adjust in such a way that you can point the device at the celestial pole, you can now use the C-star in an equatorial mode. And I think the idea there is that you can take longer exposures than what are available in the alt-az. So again, and I think this is probably a lot of the meat of what we're going to talk about this evening is when you say, do you need to guide? A lot of it comes down to the type of scope that you're using and the type and quality of the mount. Does anybody want to comment on the quality of their mount? No? That must mean that we all have those high-end mounts.
Are you talking about the C-star mount?
Well, you can comment on that if you'd like, yeah.
No. It's just an old Z mount. I think they don't have their own wedge mount yet for the C-star. That's something you have to buy third party if you want to do equatorial.
But they do have the equatorial software, right?
Yeah, it's in the software, but it requires a wedge.
Yeah.
And
I've heard of people putting them on a tripod. If you have a
yeah, you
tripod,
can't put it on a tripod, and you have to be careful about where the front tripod lug is facing. There have been people that have had little accidents where the whole C-star has come off in the middle of an imaging session. I've seen pictures of it. It's not pretty. But you have a wedge, and then depending on the wedge you get, you might have to get like an Allen screw thing because the knob is so big it can whack the bottom of the C star. I personally am waiting for ZWO to come out with their own certified tested wedge because I'm a little freakish on getting something that's a third party one for it. But I know it can be done. I was advised by Scott at Star Zone to wait on that one.
Okay.
I do have myself. I started out with the C8 and I have the AVX mount currently. I'm looking to upgrade to an AM5 eventually, but I have the AVX mount, and that's been kind of maligned over the years as not the best quality mount. But with my configuration, I could see if you had more weight on it, it would be a problem. But with my C8 and my Hyperstar and even imaging from the back of the image train with it, with a off-axis guider, I've gotten some really good results with it. It just depends on, what scope you're using on it. If it's a real heavy scope, you're adding a lot of weight to it, it is sensitive to that. But if you keep your weight limit, at least half or less than half of what the rated weight is for that mount, you can get some pretty decent guiding with it.
David, you get more out of that AVX mount than any one I've ever seen. I had one, I started with one and it was a piece of junk.
Yeah,
Despite how many times Dean at Arizona worked on that thing,
yeah,
it was terrible. I finally went to the EQ6, like the picture here, but
yeah.
I
And
think
that would be
you
a
were
nice mount.
fortunate you got a good one.
Well, I got it. I got one of the later releases of it. Plus, I know when I was starting to do polar alignment with my ASAR, not to get off topic, everyone was telling me you had to do all these gyrations where you have to move at a certain amount of degrees and everything. And then I found out that all you had to do was sync the mount with the ASIR first, and then the polar alignment went along fine. After it plate solid, everything worked fine. But I think it was because of the release of the AVX. There were different releases of it. And then also from a guiding perspective, and I'm sure we'll get into that later, the guide camera is very important. And some people will just go cheap with the cheaper guide cams. And then when you attach it to an OAG for use in, say, the back of the C8, it's prone to failure because you really can't see the stars for guiding with a lesser. You have to have a 174 ZWO camera to get the proper amount of viewing for stars that you can for guiding. That's a big factor. And depending on the SCT you get, like with the C8, that's one of those. I always heard from Star Arizona, oh, well, it's different for the C8. Everything was different for my C8 because of the opening in the back and what OAG you had to go with. So there's a lot of different things I had to deal with and research and get the guidance of Star Arizona before I would commit to getting all the equipment. But I appreciate the comment. It was just, if I would have changed to a different OAG or a different guide cam, it would have been a different story for me.
Well, David, hold on to that because we're going to get to OAGs here in just a bit. So, yeah, I think we could spend an entire meeting or two talking just about different mounts and problems that you run into. So I'm going to try not to dwell too much on them. But again, I think if you're serious into astrophotography, you've probably heard more often than not that the mount is probably the key piece of equipment that you need to spend your money on, that you can put a marginal telescope or lens or optical system on a really good mount and still, produce pretty good results. But the opposite isn't necessarily true. Any other comments or questions in terms of the type of scopes you use or the mount?
I've got a comment, Greg.
Yeah, go ahead.
I saw your next slide is going to go to how. And so before we go to how, maybe a comment about polar alignment and periodic error correction. And the subtlety there is that even if you have a mount that isn't, really great, if you've got a mid-range mount and you're skilled with it, you can do, a good polar alignment, and you may have access to periodic error correction. You can do some magic there where you're not so heavily, demanding on your guiding. The worse your polar alignment is, and if you've got a lot of periodic error that you haven't addressed in your mount, then you're going to make guiding work a lot harder. And so I think even if you do know that you want to guide because you have a long focal length scope, if you have access to learn how to do a good polar alignment and to do periodic error correction in your mount, you're always going to be better off than if you didn't, right? Even with guiding.
Yep, I agree. Any other comments or questions?
Could you perhaps elaborate, briefly on, you mentioned the Schmidt cascade, there were modifications that could be done to improve it.
Well, off the top of my
Stability.
head, putting a second party focuser on it and locking down the mirror is probably the thing that most folks find necessary in order to keep that, primary from moving around when you do focus. That's probably the biggest issue, I guess.
And how would you do that?
Well, you mount a external focuser on the back of the scope, and then you lock down the mirror so that you get it close to focus with the built-in focuser, the one that slides the mirror up and down the baffle tube. And you get it close to focus, and you lock the mirror down so that it no longer slides up and down the baffle tube, and you use the focuser that you've attached to the back of it to achieve focus. I think that's the modification that most folks end up doing.
Yeah, I'm not exactly sure what you mean about locking down the mirror, other than locking the knob so it can't move. How would you lock down the mirror?
Well, there are attachments that you can use. There's various different ways of doing it. You can drill holes in the back and put 3 bolts in, to hold the mirror in a fixed position. Once you get it in the appropriate place. I think if you go online and search for external focusers for Schmidt-Cassegrain OTA, I think you'll find that there are several different ways you can go.
Okay.
Good question, though.
Is anybody else using a hybrid type like the ZWO AM5 in mounting system? I'm running a CPC 1100 that we converted. We deforked that early last winter in November. I just heft an almost 80-pound optical tube with that alt-azimuth mount on it, and then packing around the wedge. I guess my body isn't as in shape as it used to be, and every time I use the telescope, it was like, oh my God, how am I gonna assemble this without dropping it this time or whatever? Anyway, I've had good luck with I've done pretty well with the mounting system on there, but I see when I go down to places like Arizona, I see a lot of people shopping for those things, and like I say, mine seems like it works pretty well. But my error, I think, last week when I was running, I went out to Picacho Peak State Park. I was running out there. I was guiding at like 0.09, 0.08. 0.03. I mean, the guiding was working superbly on it. Had one of those rare windless nights where we didn't have the wind trying to push everything around, make the mount work harder.
Okay.
And you're using an AM5. I'm not sure what the question was because you started
Well,
off
it's
asking
not
about
there's
people
not
with
not really a
AM5s.
question. I'm just curious. You've got the equatorial and alt azimuth stuff listed there, and I know that AM5 in as kind of a hybrid. It can kind of go either way depending on how you want to configure it. So I'm probably running mine in equatorial mode.
Right.
Yeah, I think that's the way most folks use it. All right. Well, let's talk about then how you can guide. I'll start off briefly mentioning a guide scope because I think that's what a lot of folks do when they decide I need to somehow guide my scope in order to take longer exposures. And whether you use a guide scope or a off-axis guider, those both require an additional sensor or a second camera. So the size of the guide scope has always been something that's been somewhat of a controversial issue, with a lot of older literature suggesting that you need a guide scope that's at least a third of the focal length of the imaging system. I'm not sure how true that is anymore with the cameras that we use now, for guide cameras with the small pixels, but that was kind of the rule of thumb for a long time. But the main issue, I think, is that a guide scope has to be mounted in a very secure fashion, optimally affixed to the imaging scope in a way that allows the information that's passed to the mount from the guide camera to reflect what's really going on with the main imaging train. So I've listed some pros and cons there. The guide scope can be used with most types of imaging scopes, and it's not affected by filters in the imaging train. The imaging train being the main imaging device that you're using, that you're trying to guide. It's oftentimes required for fast Newtonian scopes because a lot of times the fast Newtonian scopes don't have adequate back focus to allow an off-axis guider to be inserted. And I know that for a fact because I own one. The wide field that you can get with a guide scope typically makes guide stars easily available. And by guide stars, we mean the stars that you're going to point the secondary camera at in order to send information to the mount. And it doesn't have to be carefully aligned with the main guide scope. It just needs to point in the same general area. The cons for a guide scope, or as I mentioned already, the mount, how it's mounted is crucial. It needs to have a rigid focuser if it has one at all. And it can't really compensate for the movable optics like those that we've just talked about in the Schmidt-Cassegrain, the unmodified Schmidt-Cassegrain. So I've got a couple of images there on the slide. The bottom one is probably the worst type of guide scope that you could imagine because it's held in place by 3 thumb screws and it's on a tall, thin stalk that has to be attached to the main optical tube somehow. So that really makes it susceptible to motion, whether the motion comes from something being loose or from the fact that just mechanically there's too many moving parts there. It also, if you see at the back, it has a thumb screw to allow you to insert the guide camera, which is good because if you can eliminate any type of a focuser from the guide scope, you see the one at the top actually has a focus wheel. And again, if you introduce a focuser into the guide scope, that becomes a source for movement, either because of gravity or because of some sort of flexure between the guide scope, the mount, and the imaging scope itself. So ideally, you'd want to have the guide scope mounted with something like you see at the top image there, which is some sort of clamshell type of device which holds it securely in place and then can be mounted firmly to the optical tube or to the focusing device itself. And again, some of the guide scopes that are available don't come with a focuser. You simply get rough focus by moving the guide camera in and out of the draw tube until you get close to focus, and then you do final focus by rotating the primary at the front of the guide scope. And that seems to be the most appropriate way to avoid all of the problems that can occur when your guide scope isn't firmly attached in such a way that the mount accurately tracks the optical scope that you're using for imaging. So I'll stop there and wait for your comments or questions in terms of guide scopes.
Greg, let me just underscore something that you said.
Okay.
Optimally affixed to the imaging scope. That means literally affixed to the scope, not connected to a dovetail plate, which is affixed to the rings that hold the scope, which is the way mine is set up. My telescope, it's not possible to, unless I wanted to drill holes into the telescope, it's not possible to mount the guide scope on my telescope itself. But that I learned in the process of setting up my rig is the optimal way, because that way any movement or change in position commanded by the guide scope gets reflected in the telescope. If you're going through a chain of rings and plates and other things, there are opportunities for things to get lost for differential flexure and so on.
I just where he meant a few minutes ago.
Yeah, I think the term there, I didn't have it in the highlighted in blue and I didn't put it in, but differential flexure is what you hear folks complain about the most when using a guide scope. And again, it's just like Jeff described, when the guide scope is not attached directly to the optical tube, and sometimes even when it is, there are lots of sources for flexure. The main ones are how the guide scope is mounted, whether or not the guide scope itself has a focusing mechanism, which tends to flex, and then whether or not the main imaging scope has a focusing system which allows flexure as well. So there are lots of different areas where you can get differential flexure when you're using an external guide scope, and that's why a lot of folks start out with a guide scope, excuse me, and then decide that they need, because they see trailed stars or stars that are not round and long exposures, that they need to go to some other method.
Well, I'll just add in your fifth bullet under pros, I think is subtly related to the same concept, not in a flexure way, but the closer you can get that scope to be aligned to your main optical axis, the better off your tracking is going to be, and you can avoid some elongation, some eccentricity in your longer exposures by making sure that guide scope, which typically has a wide field, is not way off in the boonies and compared to your target, right? If you get them reasonably close to each other, as close as you can without being perfect, you're going to be better off.
Yeah, and I think the example that you see at the bottom there, that Orion guide scope with the 3 thumb screws, those thumb screws are there to adjust the pointing of the guide scope. And that's, if you're using it as a finder, that might be very important. But as for a guide scope, you generally need it to be just aligned with the main optical tube, as Doug pointed out. So again, if you can avoid the thumb screw type of mounting, that's just another source of movement or possible differential flexure that you can avoid.
For the impression that having the guide scope, almost exactly aligned with the main scope is not important. You just have to be close.
Yeah, close.
I mean, they're kind of, if it's pointing close to the same area in the sky, it's reflecting the tracking of the scope. I mean, if you're polar aligned, it should reflect it even if you're quite a ways off, right?
Well, you can be off a little bit, but like Doug pointed out, I think the closer you are to where the imaging scope is pointed, the better off you're going to be.
There is one additional pro for using a guide scope. If you mount it to where I do mine, I have an upside down Vixen dovetail on the top of my scope. And then I use a pair of ADM clamps uh, to lock down the rings for my guide scope. And what that allows me to do is when I'm balancing the scope, especially in deck, you can fine tune it very easily just by moving the guide scope backward and forward on that dovetail. It's a lot easier than shifting moving the entire weight, for instance, of a C11 with everything attached to just move that guide scope somewhat.
Good point. I knew somebody would come up with something that I hadn't thought of, so thank you for that. All
Can I
right.
add something for a second? When you're talking about aligning the guide scope to the main scope, like the one you showed with the thumb screws, it's probably, isn't it better to, my guide scope is on top of a Vixen plate with a clamshell, and so it's not adjustable. But I would still, that's probably better than having something like the Orion that you can adjust to line up with the scope. But
Yeah,
then
yeah,
you have
yeah. I think if you have something like the top image there where it's sitting on a dovetail plate, it's not ideal, but it's certainly better to have the clamshell type of arrangement. And unless you really mess around with it, it'd be difficult to not get the thing pointed in the correct direction, I would expect.
right.
Yeah, one other thing too is might be a little nitpicking, but it's more important to get the guide scope aligned with the main optics, particularly in declination, more so than right ascension because the rates are a little bit different as you go north-south.
We'll get to that. Okay. So the other way you can guide, and you're probably familiar with this already, is the off-axis guide, OAG. Again, requires an additional camera and operates pretty simply on either a mirror or a pick-off prism that gets stuck into the optical path that doesn't interfere with the light cone that's going to the main sensor. And the pros behind that are it works well with the Schmidt-Cassegrain or refractor, and it can be used with some Newtonians, but not all, again, because of the back spacing. And it can be placed in front of any sort of filter train in a lot of systems so that the guide stars are not impacted by the filter that's being used to work with the main imaging camera. And does have some drawbacks. It's sometimes difficult to get to focus, to get what we call parfocal. In other words, typically you have to move the camera in and out the guide camera in and out in a fashion in such a way that it's in focus so that the guide stars can be picked up by the guiding software. The fact that the mirror's in a particular location means that guide stars may not be readily available. Now, some devices allow you to rotate the off-axis guider so that if there's a guide star at the bottom of the field of view, you can rotate it around and get that guide star on the prism so that it can be used for guiding. But again, because the prism is generally pretty small, it's sometimes difficult, if not impossible, to find an appropriate guide star. And again, unlike the guide scope, which has its own focal length, the off-axis guider is dependent on the focal length of the imaging system. So again, that's both a good thing and a bad thing. So if you're trying to image at 2,000 millimeters with an f8 optical system, it's good that your guide scope is at that same focal length because you need to guide very carefully at that long focal length. And having the off-axis guider there will make it work fairly well.
Yeah, I have the same ASCAR OAG. It is fantastic, and it pairs well with my C8 and the 174. It just drops all the way in. The only issue that I have, because I haven't had the guts to do it on my own yet, is every season when it comes to Galaxy season, I have to schlep out the Star Arizona and bring the C8 with, and then Scott or Steve or somebody there will focus it for me because I don't have a really good view of something in the distance, like a mountain, to focus it on. So I'll just bring it there, and I think Scott took like 60 seconds to pre-focus it for me. And then I was able to get it in focus when I brought it home and set it up.
Did you put a ring on it so you could put the camera back
Go
in
ahead.
the same place every time?
I'm sorry, what was that?
Well, you know, the little eyepiece rings that you can buy to make the eyepiece parfocal. You might find one that fits around your guide camera and put that ring on there, so that even if you didn't do that, you could put a piece of tape on it so that you can insert the guide camera at the same point every time.
Yeah, that's a good point. I mean, I just everything was like it's all in one unit now. All I got to do when if I take the unit down for some reason, let's say we have a lot of wind, I bring it inside, put it back in the case. Um, I can just insert it right into the scope and I'm all set. And the guide cam actually, the way Scott fed it in, it just goes all the way in. There's nothing to adjust with the guide cam for this model at least.
Oh, okay.
And it does have that little focusing knob there. So there have been times where I needed to more finely focus the guide cam, and all I had to do was use that helical focus knob, and that took care of the whole thing.
Does the focus knob move the mirror in, the prism in and out?
Um, I don't think it does. I think it just moves the camera slightly.
Only moves
Okay.
the camera.
Yeah.
I can give a second opinion on the OAG because about 3 years ago I went down this path. I had a ZWO OAG, one of their first ones. Maybe this is even 4 years ago, and I bought it from Star Arizona on their recommendation. I said I needed an OAG, but I didn't do any research myself, and that I was given kind of a guidance of, oh yeah, there's the ZWO OAG and a 120, and you can do uh, off-axis guiding, and I struggled horribly to find stars. I was always rotating the OAG. It was, I gave up on it. And then I started doing some research, and part of the reason was I guess there's good OAG and camera combinations, and I'll call the other ones bad. um, because you're buying this for long focal length stuff. So you want a big prism in the OAG, and the ASCAR provides that. You want a big window. So some of them have big prisms, but then the window going up to the camera is small. And that was one of the problems that the ZWO had. It didn't have a big prism, but it had even a smaller window of area where the light could go up into the body. So you want both of those, and then you absolutely want the 174. And when I went to this setup about 3 years ago, it was the first ASCAR that Star Arizona had brought in. It was night and day, and it works always. And I almost always get multi-star guiding without messing at all with a rotation or anything. So if you're thinking about off-axis guiding, this setup, that the ASCAR with the 174 absolutely works.
Yeah.
So,
Great.
It doesn't work for me. I've been
Uh,
trying it and trying it, trying it, and I have yet to have that thing pick up a star. Uh, I've had, I actually quit using mine, trying to use it a couple of weeks ago because it was just frustrating as all get out. I'm struggling with it. I don't
You
know.
have a C8 or what do you have with it?
Well, I'm using a CPC 1100, and then I'm using a 170 ZWO 174 on it. And like I say, I have yet to actually be able to pick up and guide anything with it. You know,
Sure, you're
it's,
using the ones, I thought earlier you said you were using a 120.
oh no, 174.
Okay,
And
okay.
the CPC, is that like a C8 only on a fork mount or?
No, CPC 1100 is their big 11 inch
Oh, God.
model that, you know, I guess I could probably refer to it as a C11 and everybody would
Okay.
understand that better than
Do you have a
CPC 1100.
reducer? Do you have a reducer?
Yeah, I'm using a Celestron 6.3 reducer in the imaging train with it.
I avoided getting the Celestron for my C8 specifically, and I got the Starazona's SCT corrector reducer because there was something about, at least with the C8 and the opening, that using the Celestron, it was a combination of different things. It's not just one item. So it was a combination of using the ASCAR OAG for me, the 174 camera, and the SCT reducer as opposed to the Celestron model. And it had something to do with the amount of light that I would get into the OAG, into the prism. And it was multiple points that I had to deal with. So I'm not sure about your situation exactly, but
Yeah, they assured me when I bought this from them here a while back, because when I bought the telescope, it came with that particular reducer, and they assured me, oh, that reducer will work great. But
yeah.
so far, it's just been an exercise in frustration for
It
me.
might be where you have that prism can be located, moved up and down,
Yeah, I've
and
tried
maybe it's
that.
just too far out of the line of sight.
Well, I've pushed it down. It's down as far as it'll go now. I've tried it. I've tried moving the mirror up and down, and Scott did I went down there and they, you know, when I bought that thing, I took my scope with me and everything. We set everything up and he pre-focused it on the mountain and all that kind of stuff. But so like I say, so far I just haven't had any luck with picking up any guide stars with it.
Is the reason that the 174 works better is because it's a bigger chip?
Yes.
Okay.
It's like
That's-
twice the size,
Yeah.
maybe even more than the 120. It's a lot bigger.
Okay. So that's an important issue.
Yeah, and a 174 just on its own doesn't necessarily work if you've got a small prism. So there was on cloudy nights, when I was doing this, there was some really good articles where people overlaid the different sizes of the prisms in the OAGs and the camera size. So you could see which ones worked well together.
Okay.
And I think a long time ago I sent that article out to the group. I could probably find it again for those that are interested in off-axis guiding.
Yeah, that might be a good idea. Okay. The last how to guide is if you have a built-in guider. And again, this goes back all the way back to SBIG's original design for their dual guiding CCDs, but that's kind of gone by the wayside now. But now we have the ZWO Duo series, and I was looking at some stuff on cloudy nights, and there was a lot of discussion about the fact that you need an imaging system that produces at least a 44 millimeter image circle in order for the little guide camera there at the bottom to actually function properly. So the pros behind having the two cameras built in together, obviously they're in the imaging train and it's parfocal kind of the way it's designed. You have the electronics are all combined together there, especially cooling. Most guide cameras are not cooled, but in this case they are. In this case it would be. And this is ideal for one-shot color cameras because you're not worrying about any filters in front of the guide scope, the guide sensor. The cons are
wait, Greg, why wouldn't you possibly have an IDAS NBZ or the Antlia Tri-Band or something in front of the 2600?
Well, you could
Okay.
have one of those, but they're ideal if you don't have a filter.
Fair enough.
Okay. And what I saw online was pros and cons. Some folks claimed that the filters, you could use it with the filter, and others said, no, it doesn't work very well. So the cons are that the guide stars may be limited because the sensor is in the same place in comparison to the field of view of the imaging scope. So unless you have a rotator where you're going to rotate around, usually you rotate in order to compose the main image, but you may be forced to do that to find a guide star as well. Again, the focal length equals that of the imaging system, which is good. But again, that makes the guide stars fainter if you're talking about a long focal length or a slow focal ratio. And it may not work well behind filters, especially narrowband. I think ZWO actually has a camera, a mono camera in the Duo series, and there's been a lot of discussion about whether or not that's a good idea or not, because the guide sensor is going to always be behind the filters when you're doing RGB or even narrowband. Craig, I think you have one of these, don't you?
I don't know about Craig, but I have one.
Oh, you have one. Okay.
Yes.
How's it work?
Well, I'm no longer using it. I've been back to my guide scope, at least on the C11. For one thing, it was not parfocal with
Wow.
my scope setup. But they do have, which I didn't realize in the beginning, that they have a little knob on it that you can turn that I guess it varies the distance of that little small sensor, but it'll help you to focus it. If
Yeah, that
you,
knob at the
I find
bottom in
it
that
did not
picture.
work well with any narrowband filters, that it became a real struggle. And especially if you're using dual narrowband filters, which is what I usually use, an NBZ or a tri-band.
Yeah, one of
something
the
like that.
the
It just did not
advertising
work
things
well.
that I saw online was you don't have to use the built-in sensor. You can use an external filter. So
Yeah,
then you have another camera to worry about.
yeah. So basically what I have, what I'm using is I went back to what I was using before. I got the Duo, which is a guide scope with a separate camera. And I
I
use
do
an
have
old
one of these.
80 millimeter Orion short tube with which has a focal length of 400 meters.
Any other comments on the Duo C, or is anybody else using it?
Well, the
You
only
go
thing
ahead.
I heard from various folks was depending on the bandwidth of your filter, that will affect it. So if you have a really dark, narrow filter for dual narrowband imaging on a one-shot color camera, like a 2600, for example, the Duo model, it can affect it. I think if you're just using a regular light pollution filter like an Optolong or a tri-band, it probably wouldn't have as much of an issue. But just depends on the filters you're using. You got to watch it. And I've seen YouTube videos as well where they're reviewing it and saying, you got to watch the bandwidth of your filter.
Okay. All right, so let's kind of pull this all together and talk about what you're really interested in. That is the guiding software. So most of the dedicated imaging packages like Maxim, the Sky, and APT come with a proprietary guiding software included in them. And typically they can use various different approaches, whether you have an off-axis guider or a guide scope or a built-in guider. But probably what most of you are using or most of you are familiar with is PhD2, which is a standalone guider. And I think the ASIR uses a knockoff version of PhD2. So the guiding software obviously turns regular guiding into auto guiding. We haven't used the term auto guiding, but that's really what we've been talking about all along. And again, I think the prototypical package that probably most people use and most are familiar with is PhD2. One, because it's free, and two, because it is very, very sophisticated in terms of what it allows you to do. Any comments or suggestions along those lines? Okay, I've used Maxim DL for 20 years or so, and I've used PhD too for quite a while as well. And I find that both of them operate in a similar fashion. In other words, you can use a single star or multi-star guiding. They give you a graph, like the graph you see down there, that shows you exactly what's going on with your guider. It allows you to see what types of excursions the guider is picking up, whether or not the corrections are actually displayed. You can set the graph up to display either in pixels or in arc seconds. And of course, you're probably better off displaying in arc seconds because that's going to relate back to the resolution of your main imaging device. And then, of course, there are all the controls that are built in. So in terms of guiding software, a few of the things that are important to think about, calibration basically shows the software what kind of a mount you have and how the mount's going to respond when input is provided. And you need to go through a calibration according to the way it's prescribed for the particular guiding program that you're using. It's not important to have the RA and DEC on the X and Y axes. And I think if you look in the literature for PhD 2, they make a point of that because basically most mounts use pulse guiding, and most mounts can send pulses to the mount for both axes at the same time. Some of the older mounts couldn't do that. So it's not 100% necessary to have the axes consistent with RA and DEC in the sky, but I found that it's useful if you have a DEC drive that has a lot of backlash in it. You don't want to be doing a lot of DEC adjustments if you don't have to. And as far as that goes, sometimes then it's useful to have the DEC on the y-axis and the RA on the x-axis and the DEC on the y-axis, so that you can easily tell what's going on with guiding. And as the guiding program suggests, it's a good idea to do the calibration near the meridian, high in the sky, and near the celestial equator, so that the calibration factors that get generated represent the largest types of movements that are going to be required to be sent to the mount. And once you get a good calibration, typically that calibration can be reused. Dark frames are usually needed for uncooled guide cameras. So you notice that when you set up PhD 2, one of the first things it asks you to do is to create a dark library, because it assumes that your guide camera is not going to be cooled. And that's typically the case with most guide cameras, particularly those that are external. The term aggressiveness is a control that the software provides that allows you to adjust how much of the calibrated corrections are actually sent to the mount, so that when you do the calibration, you generate a set of correction factors that are then used, but you can adjust those by adjusting aggressiveness. The term backlash is most important and probably only important for the DEC drive of your mount, because the RA drive is running continuously and typically has little if no backlash in most modern mounts. However, the DEC, which doesn't operate continuously, only when a DEC correction has to be sent to the mount, then backlash becomes important, because if the mount doesn't respond immediately when a pulse is sent, when a guide command is sent, then it's going to lag behind. And there are all types of ways of correcting for that. Most of the software has different built-in ways to correct for backlash. One way that a lot of imagers do is to have their polar alignment slightly off, so that all of the deck corrections go in the same direction. And that allows you to avoid deck backlash to a great extent, because the deck motor never goes in two directions. It only drives the mount in one direction, and that requires simply that polar alignment is not dead on, but may be off by a few arc minutes in order for backlash to all go the same way. And in fact, PhD2 actually has an option where you can select to only activate the deck in one direction. And then another adjustment that most of the software offers is the min-move adjustment, which tells the software to don't move the mount, don't obey a command if the amount of move that's commanded is less than a certain number of arc seconds. And so the min-move allows you to prevent the mount from chasing bad seeing or other issues that may come up, wind or bad seeing, and is very important. And again, PhD2 has a nice way of allowing you to figure out what a good mid-move setting should be for both the RA and the deck axis. So the last slide I'm going to show you is this one, and it's the good old guiding graph, and the guiding graph is your friend because it's what tells you what's going on. And you can see here the guiding graph is set up to have the scale on the axis in arc seconds, and this would be what we consider very good guiding, less than 1 arc second deviation in the movement of the right ascension and declination axes. At the bottom, you see the, in PhD2, you see the important adjustments that can be made. The circles show you that the aggressiveness adjustments in this particular example, the RA aggressiveness has been set down to 70, which means only 70% of the full movement is sent on any one adjustment command, whereas the deck aggressiveness is set at 100%, so that when the deck sends a command to the mount, the entire command is sent. It's not reduced by any given amount. And then the min moves are pointed there by the arrows. You can see they're both approximately the same there. And again, those can be adjusted up or down, but probably you're better off to let the software figure out what the best min move values are, particularly in PhD2, because it does a really nice job of that using the guiding assistant. And those are the main adjustment factors that are available in PhD2 and other guiding packages as well.
Hey, Greg, if I could just underscore, you in this picture, you show a bunch of variables, then there's buttons, and you can push the buttons. Just because you can push the buttons does not mean you should push the buttons. For those of you, just to remind everyone, PhD stands for push here, dummy. And what they want you to do, their instructions are, there's 4 buttons across the bottom: connect equipment, find a star, or loop, find a star, and guide. That's all you need to do if you've configured the software properly. So take it from someone who, I won't explain how I know this. I'll just say I know this. Don't push buttons unless you know what you're doing.
Yeah, and as I said, PhD2 has, well, it has a calibration assistant to help you get close to the meridian and celestial equator, so you can get a good calibration that can be reused. It allows you to create a dark library, so you don't have to do that every night. And it has the guiding assistant. This is the last slide. These are 4 YouTube videos. They all come from Bruce Waddington. I contacted Bruce. Well, actually, I contacted Andy Galasso, and he said, no, I don't do that anymore. You have to talk to Bruce. So I called Bruce, and he said, no, I don't do that anymore. But here are 4 videos that I've done for similar lectures, and they're all very good. The first one up there is on the guiding assistant, which is the thing that allows you to really dial in the guiding for your particular scope and guiding setup. And all of these go into great detail in guiding, a lot more detail than we've gone in here tonight. I would suggest that you start with any one of them. The top one is the guiding assistant, but the other ones talk about all the different features of PhD2. So even if you use some other guiding package, there's a lot to be learned by looking at any or all of these YouTube videos from Bruce.
Hey, Greg, before you go on, I'm not sure that this hour addressed Jim's question from the very beginning.
I'm sure you're right, it didn't.
So I just invite us to go back to that.
Well, I'll tell you how I do it. I plug my guide camera into the USB port on the imaging camera because it's a nice sharp little cable, and then I allow the imaging camera to manage that port with my mini computer that's attached to the tripod. So that's one approach. I guess you could run the guide camera directly to the computer that's running your software. If you're using the ASI Air, I guess we go directly to that. But it seems reasonable to use those USB ports that are built into the ZWO cameras, and I think built into some other cameras as well.
I had a question, Jim. Were you talking about running the guide cam directly into a guiding port on the mount, separate and independent from the computer that's running your rig?
Yeah, I didn't realize there were two different ways to do it. I'd rather connect into my cooled camera because the cable is shorter and it wouldn't get tangled up trying to get down to the EQ6R. So I didn't know if it was better to connect direct to the mount or running it through the camera through Nina and sending corrections to the mount. I mean, I'm sure both ways would work, but it just seems physically to make more sense to put it a shorter cable. I mean, just
I think there is a difference. I looked at this a long time ago, but my understanding is given the choice of bypassing Nina and having your mount talk directly to the guide camera versus running everything through Nina and PhD2, you absolutely want to run it through Nina and PhD2.
Okay.
And not bypass the system.
Okay, thank you.
Others can tell me if I'm mistaken on that, but that part of that analysis, the conclusion I remember clearly. The why, I'm afraid I can't explain.
Well, if you bypass the guiding software, then the guider is going to be operating independent of the imaging. And if you stop to do an autofocus or something, guiding may work through that, but it may not. So there's probably several reasons to do it.
I think he's talking about the ST4 connection, which is an ancient way of guiding, but
Yeah, I didn't even.
practically every mount still retains that.
I had an
People
ST4.
just refuse to use a computer.
I had an ST4 many years ago, and it basically was just a mechanical relay that hooked directly to the mount.
Yeah.
And there was
very unsophisticated.
Yeah, there was no display of anything.
Yeah.
If it worked, you were lucky, and if it didn't work, you had no idea why it wasn't working. So
that makes sense. Thank you.
Yeah, that was something different. Other questions?
You used a shorter cable, Jim.
Thanks. That's what I wanted to hear.
Hey, Greg, could you go back to your second to last slide for a second, please?
Whoops, too far.
Yeah.
This one?
No, the guiding graph.
This one.
Yeah, you notice on the graph, right ascension is in red. And one of the useful things about the guiding graph is that you'll notice here that almost all the right ascension corrections are skewed in one direction. That might be that might be guiding east or west. I don't know what direction it is, but it could indicate that the mount is systematically running a little bit slow or a little bit fast. And one of the things you can do if you have a mount that has a custom right ascension rate available in the software is to just tweak that until those corrections basically go away.
Yeah,
And you got nice guiding that way. It's
yeah,
easier.
that's interesting. We didn't really discuss that in great detail, but if all of the guiding corrections are in the same direction, particularly the deck guiding corrections,
Hmm.
then
Hmm.
that usually an indicator that your polar alignment is not perfect. And that's not a bad thing, as I mentioned before. By having the polar alignment off by a few arc minutes, all the deck corrections will be in the same direction, and that prevents or that kind of minimizes the amount of deck backlash. But if you see a graph like you see here, where there are a lot of corrections in RA, you typically don't see a lot of corrections in RA unless, like Tom said, the RA is running too fast or too slow. Generally, though, there's fewer corrections in RA than you have shown on this particular example. This is right out of the PhD uh, help manual.
Yeah, and also they have a checkbox there on the left, trend lines.
Yeah.
That's not checked here, but if you do check it, it will build up a trend line. So, for example, if you have polar misalignment, you'll see the trend going either up or down, north or south. Gives you a good indication of which direction you're off in polar alignment.
Yeah.
Unfortunately, they don't have that on the PhD version in ASI Air.
Hmm.
I wish they did, because it is very useful.
Well, the other thing that's important in all this too is seeing. There's a lot of people I've noticed that seem to struggle with trying to compensate for mediocre seeing by adjusting PhD parameter settings and so on and so forth. And a lot of people maybe not have success with that, and they think there's something wrong with their tracking or the mechanics or software of their mount and so forth. And if you do a lot of imaging, you pretty quickly come to realize how important seeing is to this whole thing, not only for the quality of your image, but also the quality of the guiding. So, for example, if you have a good night of seeing and you want to test your system, it's a good thing to point at some high altitude or, more or less overhead near the zenith somewhere, maybe 20 degrees either side of the zenith, and do a guiding run. And under good seeing conditions, it will really tell you how your system is working with minimal aberrations caused by, atmospheric disruption and so forth, or dispersion.
One of the things that you'll find at that first video that I referenced below from Bruce Waddington and talking about the guiding assistant, he makes the point of if you have a night of mediocre seeing, you can point your scope at your target and run the guiding assistant, and the guiding assistant will quickly tell you, what might need to be changed in terms of the min move and the aggressiveness. So one of the things that, and you only have to run it for a couple minutes. You can run it much longer than that if you're trying to characterize your system. But even running it just for a couple minutes will give you a pretty good handle on how the seeing is, and will give you some suggestions as to what you need to do in terms of making those adjustments. In fact, you can just click the button on the guiding assistant and it will insert those min move values and aggressiveness values.
Yeah, yeah. And
What
you'll
about
find that
exposure time? Has anybody has an idea? I try to keep mine within about a second, 1 second to 2 seconds exposure time. Because I found if it's too long of an exposure time, then my guiding goes way off. And in the ASI Air, if you're going to do, if you're going to, I also raise on my camera, I raise the gain all the way up. And I set up a dark library a while back on the ASI Air for that purpose. That way, if there's any odd pixels, it doesn't pick it up as a star. But I found that, keeping it as close to 1 second as possible makes a huge difference in my guiding accuracy.
I found that it matters what mount it is. So
Ah,
a harmonic drive mount has got needs a lot of corrections, quick corrections. So I either use 1 second or 1.5 seconds. Some people used to recommend a half a second, and I've never had any success with that. It's just chasing the seeing too much. And if the seeing gets worse, I sometimes increase the exposure just to try to average out the seeing conditions. That's my biggest correction for bad seeing. But then I also have a Gym 45 ioptron, and I don't run it under 2 seconds. Sometimes I run it at 3 seconds just because it doesn't have as much need for correction as the AM5.
Yeah, Bruce recommends not running under 1 second because you're really sending too much information to the mount and probably end up chasing the seeing. And he also recommended what you suggested there is that if the seeing is marginal, you may want to make longer exposures so that those guide stars get averaged out a bit before the command is sent to the mount. I would recommend that you check out the videos at the end of the talk here. Okay, I got a couple of things. We're getting close to an hour and 20 minutes. Next month, our meeting will be on May the 19th, the third Monday, as usual. If you want to submit images for the bulletin, you can send those to me, or you can tell me that I have your permission to use any images that you post on the TAAA forum. Either one of those will allow me to put those images in a folder that I can then use when it's time to send them to the bulletin. And starting following tonight's meeting, we're going to talk a little bit about the monsoon challenge for this year. The monsoon challenge is when we have a set of targets that everybody tries to image, and then at the July meeting, we sit down, we compare what everybody got, and then those images get sent to the bulletin for August. So this year we're going to do it a little bit differently. I talked this over with Jeff, and he came up with some really good ideas. Instead of having a specific target, this year you get a specific constellation. You have to image a target in the constellation Ophiuchus. You have from tonight until July 21st to complete the monsoon challenge. You can pick any target in Ophiuchus, and there's a lot of targets in Ophiuchus. And the third rule is try not to pick something that you've imaged before. So we won't hold you to that. We no way we can check, but try not to image something you've already imaged if it's a globular or something you've already done. So the monsoon challenge starts today, goes till July 21st. The target constellation is Ophiuchus, and try not to image something you've imaged before. Any questions?
How do you spell Ophiuchus?
Ha! Ophiuchus. It's just north of Scorpio. You should be able to find it with your planetarium program.
Okay, great.
Can I ask one quick more question on the guiding?
Sure.
This is the first, I use a Hyperstar C8, and at first I didn't guide at all. With 15 to 30 second exposures, that worked out fine, but I am guiding now. And one of the slide right before this one, I've never heard about using darks with my guiding camera. And I use the
HD too?
I'm using ASIR.
Do you? Oh, and it doesn't require you that you do darks?
It doesn't. I've never even heard of using darks with guiding. So if somebody can explain how you do that really quickly on the ASIR, I would love that.
Hey, ASIR users, tell them how to do it.
Yeah, it's a guiding library, and you can set that up. And I forgot the actual. If you go into the menus of the ASIR, when your guide cam is set up, you're going to need to put your cap on your guide scope,
Right.
and then you'll be able to take darks for it. But it'll be specifically for a dark library. It'll automatically take them for you, and it'll store it directly on your ASIR memory chip.
And so I would just do the darks setting on the ASIR, And then let's say on my ASI Air, I will use anywhere from 1 to 2 seconds for my AM5. So I need to take darks at 1 second, at 1.5 seconds, at 2 seconds if I use
No,
those.
no, not at all, not at all. It's just
Oh.
based on the gain that you set your camera on. So it's based
Oh,
on the gain only. It's if you set your gain up high, I set mine to like 400 on my
uh,
for my guiding. That way it's really sensitive to pick up stars.
right.
And it helps with the guiding itself. Then it recommends that you set up a dark library in order to do that. In fact, I don't think it allows you to do that unless you have a dark library set up. So you have to do that first before you can crank up your your gain.
It's okay. Okay. And so the higher the gain, the more important the dark.
Yeah, it'll actually tell you you need to have a dark library set
Oh.
up in order to set the gain that high on your guide camera.
Oh, okay. Yes. I set my gain at high, but it's not all the way up.
Yeah,
It's never told me that.
yeah, mine's cranked all the way up.
The dark frame should make the guiding much better because any hot pixels or things that
Right.
happen to be there will be taken care of.
So how long of exposure should I use for the dark?
The library will give, in
Oh.
PhD2, they give you from 1 second up to 6 seconds. You can do whatever you want. But if you have a whole range, then whatever you dial in on that night, you've got a dark to match it.
Okay, so that's what I'm saying. So if I'm doing 1 second exposures for my guiding, I need to have 1 second darks.
Yeah, exactly.
Cool. Thank you so much.
I should
right.
set it,
Okay, if there aren't any other questions, we're going to call it for tonight. Thank you for attending, and I'll try to have the recording of this posted as sometime tomorrow.
Thank you for your guidance, Greg.
All right.